Hello, my name is Pasang Rumba, and in this video, I will be presenting my Assessment 3 project, an airplane seat allocation system developed using a plan driven software engineering approach. The core problem this project addresses is the efficient allocation of seats in a 90-seat airplane layout based on the various business constraints such as solo travelers, group travelers, VIP passengers, accessibility needs, and the child restriction. This simulates the real old airplane seating operation while maintaining a fairness, usability, and administrative control. Now, let's move into system modeling and requirements. I began my project by modeling the system using UML diagrams, including use case diagram, activity diagram, a sequence diagram, and a class diagram. These help me understand user roles, system behaviors, and how different components interact with each other. The system had to fulfill several functional requirements, such as handling solo and group bookings, excluding broken seats, enforcing the age restrictions, and allowing admin override. Non-functional requirement focus on usability, performance, and readability. The system architecture was designed using object-oriented principle to ensure modularity and maintainability. Now let's move into system algorithm. The seat allocation algorithm is rule-based and preference-driven. For solo booking, it prioritizes uh, windows and aisle seats, avoiding middle seats unless necessary. For group booking, the algorithm attempts to place the passenger in the same row with adjacent seats. If no row fits the entire group, admin override is triggered. Accessible passengers are designed to assign seats like A2, A10, or I10, while VIPs are assigned to the exclusive I2, I4 series. The system also avoid assigning children to row 1, which is marked as age restricted, and dynamically exclude broken seats. Let's move into prototype demonstration. This is the front end of the prototype where staff can select a solo group booking along with passenger preferences. After submitting the form, the backend processes the input using PSP and updates the visual seat grid. As you can see here, the seats are color coded by type: green for general, blue for VIP, yellow for accessible, gray for broken, and red for solo booked, and purple for group booking, group booked. If no valid seat is available, the admin override interface is triggered, allowing a manual intervention after password authentication. All the booking data is stored in MySQL database and pursued across the sessions. Okay, let's start the solo booking demonstrate the prototype. I would like to begin with a solo booking. Uh, so first select the passenger type as solo and select the passenger that I had listed here. Uh, I have listed 20 passengers right now, so I would like to go passenger one. And let's check the first. Let's check there's a VIP passenger. So if I click check the VIP passengers and allocate the seats, it will book I2. I2 it's already booked. So similarly, let's uh, go to passenger 2. If I book the passenger 1, it will say already booked. So we cannot just book the same passenger again. So I choose the passenger 2, and passenger 2 needs accessible seat. So I check it and allocate it. So here it is, the accessible seat is assigned to passenger 2. Similarly, like to go and select the passenger three, and passenger three wants no childrens around him and the passenger. So basically, it will be the edge restricted zone. So he wants to be allocated in edge restricted zone. So I would select no children and then allocate it. So here it is. He will be allocated to edge restricted zone. Now, after demonstrating solo seat allocations, I would like to begin the group booking. So the passenger type will be group, and there will be one a group leader who is going to be book the seat. So and then like number of size will be group size will be four and allocated. I think group four has already been allocated. So I will like to go to group leader two and allocate the size five, group size five, and allocate the group two. Here it is. It will assign the group to it will shine in the same row. So now let's uh, demonstrate the admin override. To admin override, we need to first we need to uh, have authorized have access to override the seat. Okay, now I want to override uh, here to passenger PASS passenger 6. Let's suppose the passenger 6 is not assigned it. Okay, so it is assigned to passenger 6. Okay, now the passenger 6 is assigned to Z2. So this demonstrate shows the prototype demonstration. All the allocation data are stored in MySQL database and ensuring persistent tracking of reservation history. Now let's move into system evaluation and personal reflection. One of the key takeaways from this project was applying a plan driven methodology in practical context. Modeling the system before coding helped me clarify logic, reduce errors, and build a scalable solution. I felt challenges in aligning real world constraints with seat availability, especially when managing group bookings and edge cases like broken or restricted seats. Following a test driven development approach allowed me to verify each component individually before integration, which improved reliability. Over this project, improved my confidence in designing, implementing, and testing a full stack system. In conclusion, this project demonstrates how software engineering principle, object-oriented design, and clear business logic can come together to solve a practical problem like airplane seat allocation. Thank you for watching this presentation.